Hello students, welcome to the fascinating world of mass spectrometry Chapter 1. Mass spectrometry is a powerful analytical technique used to quantify known materials, identify unknown compounds, and elucidate the structure and chemical properties of different molecules. The principle of mass spectrometry involves bombarding vaporized molecules with high-energy electrons, accelerating the ions, and separating them based on their mass-to-charge ratio. The main components of a mass spectrometer include the system inlet, ion source, mass analyzer, detector, and signal processor. Cations formed during mass spectrometry are separated using magnetic deflection, where ions are accelerated into a magnetic field. Their trajectories are altered based on their mass-to-charge ratio, m/z, with lighter ions deflecting more than heavier ones. This separation helps distinguish ions of different sizes and charges. The fragmentation of the ions also provides critical information about the sample's molecular structure. Smaller fragments form when molecular ions break apart, offering insights into the compound's composition. By analyzing the deflection and fragmentation patterns, researchers can determine the molecular weight of the sample. The unique fragmentation pattern serves as a fingerprint for identifying compounds. The data collected from magnetic deflection and fragment analysis are used to create mass spectra. Students, please note that, when an electron beam ionizes a molecule, it forms a molecular ion, which can fragment into smaller ions. The mass spectrometer analyzes these fragments to determine the mass of the original molecule. The mass spectrum of methane, CH4, shows multiple peaks due to the fragmentation of the molecular ion into smaller ions. In the mass spectrum of CH4, the tallest peak is called the base peak, which represents the most stable fragment. Please note that, the base peak in mass spectrometry is the most intense peak in the mass spectrum, representing the ion with the highest relative abundance. It does not necessarily correspond to the molecular ion but is often the most stable or abundant fragment ion produced during ionization. The intensity of the base peak is used as a reference, and other peaks are typically expressed relative to its intensity. The base peak provides valuable information about the fragmentation pattern of a molecule, helping in its identification and structural analysis. Hexane's mass spectrum shows peaks corresponding to the loss of various alkyl radicals, with the base peak at m/z equals 57. The mass spectrum of hexane highlights the molecular ion and the base peak, providing insights into its structure. Benzamide's mass spectrum reveals peaks corresponding to the loss of specific fragments, helping to identify its structure. Alkyl halides show a characteristic M+2 peak due to the presence of isotopes, providing clues about the molecular structure. Students, please note that, the M+2 peak in mass spectrometry represents the ion formed by the molecular ion, M+, gaining 2 additional mass units, typically due to isotopic substitution, such as the presence of the heavier isotope of carbon, C13, or chlorine, Cl37. The intensity and pattern of M+2 peaks are important for identifying isotopic variations within a compound, offering insights into its elemental composition. The mass spectrum of 2-chloropropane shows 2 molecular ions, indicating the presence of isotopes in a 3:1 ratio. The mass spectrum of 2-bromopropane shows 2 molecular ions, indicating the presence of isotopes in a 1:1 ratio. Students, let's discuss about the nitrogen rule. The nitrogen rule in mass spectrometry states that the molecular ion, M+, of a compound will have an odd mass if the molecule contains an odd number of nitrogen atoms and an even mass if it contains an even number of nitrogen atoms. This rule is based on the fact that nitrogen has an odd atomic mass, 14, and its presence in a molecule affects the overall mass parity. As shown in the slide, a molecule with 1 nitrogen atom has an odd mass, whereas a molecule with 2 nitrogen atoms has an even mass. The nitrogen rule helps in deducing the molecular composition and verifying the identity of organic compounds. Students, with this we come to an end of MS Chapter 1. I hope you have enjoyed it. Thanks for watching. Take care. See you in next Chapter 2. Goodbye.